good evening, good morning, good day, good afternoon from each part of the world you're joining. Welcome to another episode of the Mystifying Data Engineering series. This is actually episode 8, and this is one of the initiative of the data engineering community. I'm sure you're expecting to see Najeeb on screen today, so I'm actually standing in for him. So for people that are new, that are joining us for the first time, so this is an initiative of the data engineering community. And just to introduce the data engineering community to you, we're actually a community of aspiring beginner, intermediate, and experienced data engineer. We have a collaborative platform for learning, networking, and staying updated on the latest trend and technology in data engineering. So for our session today, we'll be talking about Apache Kafka, and today we have our big boss. I like to call him that. We have Mr. Mayowa Akinyele. He's actually a senior data engineer with Glover, a Germany-based company, and also he's also the founder of Core Data Engineering Groups. And I'm actually a beneficiary of one of his boot camp hosted by the core data engineers. So he's actually somebody you want to follow, pay attention. We're happy to have him here as he come on board to share his experience with us. Today he'll be taking us on a journey of understanding the whole Apache Kafka, how it works, use cases, the architecture, talking about consumer group and rebalance. So there's going to be a Q&A session too. For new beginners, if you're interested in joining our community, and if you don't want to miss out on webinar series like this, I'll actually be dropping the link to our WhatsApp and LinkedIn page on the group. I will hand over to Mayo Akinleyeli now. I like to call him Mayo in case I call him Mayo by mistake. Yeah, so Mayo, please have the floor.
Yeah, thank you very much, Musili. Thanks for, all of the kind words as well. First of all, I have to welcome everyone. Also, I have to share my screen, by the way. Sorry. Okay, so I believe you all can see my screen, right? Musili, can you confirm?
Yes, I can. Yes, I can.
Oh, okay, great. Okay. Yeah. So first of all, thanks everyone for joining the call. And I'd like to welcome everyone to this webinar session about a popular tool out there, Apache Kafka. I know some of us heard about this tool. Probably we don't know what it does, but it's fine. And the idea is that we want to talk about this tool so that we can introduce people to what it looks like, how it works as well. It's a big tool, and just for your information as well, this tool was originally developed at LinkedIn, and it's a popular tool used by many, many, many companies. So let's get down to it. So first of all, we have to go through what the agenda will look like, and so that we know where we are going to. So on our agenda there, we are going to talk about what Kafka is and some of its use cases, okay? And later we go into the Kafka cluster. So afterward, we talk about a platform called Confluent. And we talk about the topics, Kafka topics, partitions, offsets. Then later we dive into producers and consumers to kind of see, the relationship between both of them. And we talk about an important concept called Kafka Schema Registry. And after this one, we talk about a concept as well called serialization and deserialization. I know those are buzzy words, so don't mind them. They just like to confuse people. Consumer group and rebalancing. And we'll end the session with Kafka Connect. So I have something as a bonus as well. I mean, after the entire slides, but again, let's see what the time looks like. But regardless, I will share it after the call. So before we jump into the whole thing today, I mean, I think Musili, you already did a great work there doing the introduction, but I would just like to formally introduce myself. I know some of us on the call already know who I am, but there are some people just listening to me for the first time. And look, my name is Bayowa. I'm a Nigerian, and currently I'm a senior data engineer at Grover, a company based in Berlin. And my functions there, so I build and maintain data platform, the Grover data platform. And you can already think about, building ETL jobs and maintaining building infrastructures. And our tech stacks within the team are, the following, Python, SQL, Airflow, AWS, Terraform, Kafka, Docker. Sorry, is that? Okay. Kubernetes, CI/CD, Airbyte, and Trino. And apart from this, I'm also the founder of Core Data Engineers, known as CDE. And what do we do there? We just help beginners get into data engineering. And this cannot be possible. People in the data engineering community, selfless individuals as well, are part of the initiatives, and they are, on top of this. And we are also super grateful to them. Now, lastly, I will talk about, my hobbies. So I love to teach because I believe the best way to retain knowledge, is through teaching. So it might not be the easiest, but at the end of the day, you gain quite a lot there. I love to travel. I sleep a lot. I've said this before in the community. It's one of my hobbies. I know it's weird, but it's one of the things that I enjoy doing. And of course, I spend a lot on documentations. I love that. I love that. Now let's get down to business. What is Kafka? Now, many people have a different definition about Kafka, but for me, it's simple this way. Kafka is a distributed event streaming system. But I know it's a simple definition there, but there's a lot of noise. There's a lot of big words there. Distributed event streaming system. What's that thing? Let's break that guy down, okay? Now let's talk about what a distributed system means in the first place. Look, if you've been hearing about distributed systems, the concept is the same all over the place. They leverage what? Multiple computers. Okay? They call them servers. They call them nodes. They call them different names. So they leverage multiple computers to achieve a common goal. So that means this system, they will comprise of many computers behind the scene. And what do? They join forces together to be able to work together and achieve the same goal. It's the same thing with football team. All 11 players, they come together as one, to start playing, and, the aim is for them to do what? To win a football game. And now that one is out of the way, it's important that we understand what an event means. An event. Because so now, event, it's just a record of something that happened. We are currently on this call on Teams, right? Microsoft already is capturing this event. They already know the timestamp, how many people on this call. So they already captured that event already. So it's like an event of something that happened. Is someone talking? Okay. So, and
please go ahead, Miguel.
Okay. So, and see this as a clicks. For example, you go on top of a website, you want to register there, and, you click, you do some clicks, you register. All of these things triggers an event. You go to a store, you want to buy something, you swipe your credit card. At the end of the day, those things generate some sort of event. Okay, so that's what event means. But it's important for us to know, see it, what it looks like, because we are just saying it by word. Look, a sample of an event can look like this, whereby you go to a store. In this case, the store is a ShopRite for people who are from Nigeria. I mean, so it's a popular store in Nigeria. So ShopRite. So you can already see that this person placed an order there, right? And that order definitely we have another ID. So on the product the person bought, I mean, it's bread. The price is there, the location is there, like if it's one. And the event timestamp is being captured as well. So this is what an event looks like, okay? And now let's go to event streaming. So if we now have to define what an event streaming means, I mean, we do watch footballs, right? And we stream an event, I mean, watching the football game. I mean, so now all those things are events. So event streaming simply means you're processing an event as it happens. I mean, that's the thing. So you're processing that event as it comes. You're not waiting. So that's what, in my opinion, believe Kafka is. You can go out there, you see a lot of definitions about what Kafka is, depending on how you understand it. But I can tell you that it's definitely a distributed event streaming system. Now, let's leave this part. Let's go into some of the use cases of Kafka, because even though when we know what this guy is all about, but it's still important for us to know some of the use. Why do they use Kafka? Why? I mean, or what are some of the use cases that Kafka fits in? Let's look at the first one. The first one here, I mean, fraud detection. I mean, I believe that people who are in the banking sectors, there might be a time like, they want to score a specific customers, maybe for loans or something like this, or for some sort of, fraud detection. Or if you have a business model that revolves around you scoring your customer first, before you now offer them the service, of course, and you have to do that really, really quick, because you don't want your customers to hang in there for long. Otherwise, you lose that customer. So Kafka fits in that use case as well. And now the second one is notification center. Look, we all, one way or the other, some of us, we've bought, many things before in the past, or maybe Amazon.com or some other retail stores. And at the end of the day, when you're done, I mean, your bank just triggers something to your phone. Hey, like, something is about to be deducted or something like this. Or at the end of the day, they send you a follow-up email that, okay, this transaction has been completed, stuff like this. Look, you don't want to purchase something and you wait for, I don't know, maybe tomorrow before you get that notification. So Kafka fits into this architecture a lot. So if you have an architecture around, building a notification center system, so definitely, I mean, you can integrate Kafka into this. And this one is my favorite. It's my favorite. Recommendation system. It's all over the place. Instagram, Facebook, LinkedIn, Netflix, it's all over the place. Amazon.com. If you go to Amazon, if you purchase something now, once you place that order, they're already telling you that you may like this. Because you bought this, you might be interested in this. The same thing with Netflix. You're watching a movie and you're done with that movie. Look, they are recommending another, I don't know, another movie to you. The same thing with YouTube as well. It's the same thing, recommendation system is all over the place. Because all these people, they want to what? They want to engage you. They want to engage you. They want you to spend your money. They want to steal your attention, come around to our platform. So, and in this case, look, even if you're watching Netflix, if you watch a movie for 3 minutes, Netflix is not going to wait till you finish that movie before they recommend, because you might watch a movie and you're not interested. Immediately, they want to recommend another one to you because they want to engage you so that you don't go and kill your subscription with them. So that's on that one. And this one, I know this one too well. I know this one too well. Real-time analytics. For people who are data analysts, you can already know that, there are some reports that are bash based. And I mean, we are data engineers, and sometimes, most of the time we build bash processing, right? Whereby we wait for maybe longer hours or, something like this to be able to deliver the data. But we don't really care because the use case of the data doesn't require real time. But look at the scenario of Black Friday. I mean, this period is a popular period. And this is where C-level stakeholders, CEOs, CFOs, all these guys, they want to sit in front of their laptop. They want to look into those reports. They want to see how their products are performing. They want to see number of orders coming in right away. And in this case, batch processing cannot do it. It's real-time analytics. So that means we data engineers, we have to what? Build a real-time data pipeline. And I mean, you can't give a better tool, to help you to achieve this goal, other than Kafka. So we've, done this as well. So it fits in, completely 100%. So that's on that. Now that we've talked about Kafka use cases, let's go into companies that uses Kafka, because it's important for us to know that, so this company uses Kafka. So, wow, this company uses Kafka. So that means probably you already know that, okay, these people are using Kafka to achieve some of these things. Now, let's go into those backlinks for people in the UK. I believe they know backlinks, Datadog. So people knows Datadog for sure. So a monitoring platform. Spotify, I believe we are all conversant with that. So Netflix, Airbnb, Walmart, a retail giant in the US, and PayPal and Coursera. But there's one thing that I just want to show you here. Look at this part here. Look at PayPal. With each case of these use cases, processing over 100 billions of messages per day. So when they say messages in the context of Kafka, it means the data, the events, actually. So that means 100 billions of events per day. So, and for them to use Kafka for this, you can already picture what a beast that system is. And now we go into some other ones. LinkedIn, just like what I said, it was developed previously from LinkedIn. And Tesla as well, they use this, and Adidas. And lastly, Uber. Look at what Uber said. It's a core part of Uber's overall infrastructure stack. So you can already know, when someone orders something, they need real-time information. Real-time information. You have to know where your driver is at that moment. So all those things require some sort of what? Real-time, processes. So now this list will not complete except I have my company there. So this is Grover. This is where I work. We use Kafka there. It's critical to our microservice architecture. So we use it heavily. And now let's go into this. Why is Kafka so good? All these companies are using Kafka, and many other companies are using Kafka. That means this guy is so good on something. So in my mind, the first one here is scalability. For people who are saying this word for the first time, scale, they use that word a lot in the tech space. Scalability, see it as a scenario whereby you're getting one data today. Your system is capturing just one data today. But tomorrow, or maybe in the next 3 years, 4 years, data that now comes into your system now to grow to 1 million, 3 million. So the question is, can your system scale, to meet that demand? So that means if your system is able to meet that demand. So in that case, we say yes, in terms of scaling, your system, it's, on top, it's top notch. And in this case, Kafka scale a lot, and it's no surprise. Messages, which I said is events or data, depending on how you understand it, but in the context of Kafka, please, it's messages, okay? But you can interchange this, so events, data. So all those data, they are distributed on multiple brokers. We are going to talk about brokers very soon. So, but brokers are just like laptops. That's the way I used to say. It's funny, but that's the reality for me. They are computers. They call them computers. They call them servers. They call them instances, EC2. They call them nodes. But in my opinion, it's just a laptop sitting in the cloud somewhere. So that's the thing. Now those messages, they are what? They are distributed on top multiple computers. So you can already see why it scales really well. Now Kafka is fast, no doubt about it, because if anybody understands what distributed system means, which we are going to, we'll talk about it as well. Yeah. So distributed Kafka distributed model makes it really, really fast, because you already have multiple computers that comes together to achieve the same goal. So, and in this case, things are generally fast, when it comes to distributed systems. So that's why you see Spark, Apache Spark. It's really it's really fast. And it's using the same concept as well. It's distributed in nature. And the last one that I have on the list here is fault tolerant. So when they say something is fault tolerant, so that means that guy can, adapt to any kind of fault. It can adapt to any sort of failure. And for your information, partitions, which we are going to talk about soon, they are replicated across many brokers. So if a broker should go down, your partitions, it's already on another broker because Kafka uses multiple computers. So your partitions are not gone, so your data are not gone, so they are replicated, on top of another broker, so which is another computer. Okay, let's go to the next slide. Yes, this part, let's discuss a Kafka cluster. I know some of us doesn't care about, all of this cluster. We just want to go ahead and use Kafka, hey, I want to consume data from Kafka, build pipeline. It's the same thing for people who are coming from data engineering, beginners. All they focus about is what? Apache, what's it called? Airflow, Apache Airflow. And they just want to start writing pipelines. But the reality is, why can't we just start from the architecture? Let's understand some things there. So that by the time you eat a roadblock tomorrow, you already know where that thing is coming from. And that kind of mindset is some sort of engineering mindset. So, and the same thing goes with Kafka. Fine, people doesn't really care. It's fine. But when we read about stuff like this, it instills some level of confidence in us. And that even exposes you to more things. So now let's discuss about this Kafka cluster. But before we can talk about this guy, it's important that we do what? We understand what a cluster means, okay? And let's define this. A cluster is just a group of computers that act as one system. So that means they are like multiple computers and they act as just one system. So people see them from the outside that, oh, this is Kafka. Oh, it's one system. But nobody knows that, okay, maybe some people doesn't know that, okay, this thing comprises of what? Multiple machines behind the scene. It's the same thing for most of all these our systems. For people who are familiar with, Spark as well, for example, it's the same thing. People see it from the outside as one system, but at the end of the day, it's distributed in nature. So that means it has what? It's a cluster. It has multiple machines, multiple computers. And the same thing for Redshift data warehouse. For people who knows, it's a cluster as well. It uses the same concept. They have multiple machines, processing all of your SQL queries. So it's the same. It's just the same. Kubernetes use the same thing as well. But that's what a cluster means. So if you hear anything cluster somewhere, just know that, they use multiple computers, they are like multiple computers. Now let's talk about Kafka brokers. In the context of Kafka, those servers, those computers, they are called brokers. So see them as a node. For people who understand what node is, it's still EC2 instance. It's still VMs. Okay, it's still VMs. So they are servers. So they manage the messages that come into Kafka. And what do they do again? They manages every message that leaves Kafka. So that means all of these brokers, they are going to be a lot, maybe 4, 3, 5, depending on how big that cluster is. So that means they are going to what? They are just going to ensure that the data that is coming from the outside into Kafka, they are receiving it very well to ensure that it's stored in the right location within the cluster. And people that need that data from the outside, are processing that data and it's being delivered to them in the right manner. Now, let's now talk about Kafka cluster. Look, we've defined it, to be honest. We've talked about what cluster is, what a Kafka broker is. And now when they say Kafka cluster, you can close your eyes and just define it. It's just a group of brokers or computers. They work together to ensure that the data coming to Kafka are properly stored, and people that need that same data from the outside, they receive that data in a very fast manner. So After we've talked about this, I think we'll move to the next slide. Look, what we've been doing is good, but if we don't represent this visually, I mean, people still struggle. I mean, for me, that's how I learn. I like to represent things visually so that I can register it on top of my head. When you read, you remember the terms, the terminologies and all of these things, which is fine. But to be able to complement the whole learning, so let's represent our Kafka cluster visually, okay? So the first thing is what? We have this big box, which we are going to have as our cluster, okay? And this cluster we said is what? They are like, multiple machines, right? Multiple computers. So that means within this cluster, we have the first broker, we have a second broker, the third machine or computer, and, the fourth VM, but we call them broker or, server, whatever that you want to call it. So in this case, these guys are 4 within this cluster, Kafka cluster. So that means this guy are going to what? They are going to work together. They are going to what? They are going to work together to ensure that the data that is flowing into Kafka is properly stored in the right place. And people that will need that data, from another place, they can deliver those data to them, like, very quickly, because 4 people are working together, right? So it's going to be really, really fast. But look, even though when we have these guys like this, they are working together, right? But it's still important, even in real life scenario, we need to have a leader, and every distributed system follow that concept. It's, if you've been hearing master and slave concepts, that's distributed system they are talking about. One person has to be the leader and the others have to be some sort of slave. It follows the same concept around this one as well. But in this case, Kafka said anyone that is going to be the leader will be called what? Is going to be called a controller. So as you can see the art there, so this controller is responsible for what? Is responsible for managing the state of partitions. We're going to talk about partitions later. And the replicas. Don't forget that we said Kafka replicates all our partitions on top of all these computers. And now the controller as well undo partition reassignment. Partition reassignment. So we are going to talk about this as well, like, in the subsequent slide. Now, let's go into the next slide. Let's quickly talk about the platform called Confluent, okay? Just for us to, know what a platform is, for people who doesn't know. And before we can start talking about this, it's important that we tell ourselves the bitter truth. It's the truth, and I like to say this. Look, managing Kafka cluster at scale, it's super difficult. It's difficult. It's difficult. It's a complex system. Something that processes billions of messages. It's a super difficult system. So, and to have the right expertise there, the number of engineers that have to work around this cluster, when something failed, they have to react. It's a lot. It's a lot. And you can already see this guy, he's crying. Because people who are familiar with on-call, this guy is supposed to be spending weekend with his family. But, there's a pager duty that triggered that, hey, man, something has broken within the Kafka cluster and he needs to jump in. So now what happens is what? Confluent to the rescue. Now, first of all, Confluent is a company, and one of the people who developed Apache Kafka at LinkedIn is the founder, is one of the co-founder of this Confluent. And Confluent, by definition, is a cloud-native, full-scale streaming platform. Cloud-native is what I want to highlight there. Cloud-native, when they say something is cloud-native, just see it, please. Don't let anybody confuse us, okay? Just see it as some sort of platform that is integrated with the cloud, okay? And that's why when you go to confluent.io, if you say you need a Kafka cluster from them, what are they going to say? They're going to ask you that, hey, do you want it on AWS? Do you want it on Azure? Or you want it on GCP? So, and in a simple word, folks, Confluent help you to manage your Kafka cluster. it's a lot of work there. So it's their problem. So if you have the money, go to them, they will give you the cluster and they will manage the cluster for you. If there's anything that is going to fail around the cluster, it's their problem. And they just have to give you something which you have to connect. You can talk to the cluster, from your environment. So, we are not talking about this one here. So that is what the platform is all about. But if you want to run it distributedly, oh man, it requires a lot of, massive effort. And now we go into what Kafka topics, partitions, and offset means. I know these are a couple of things that people already are familiar with, but for people who are not familiar about it, we are going to talk about it. First of all, we go into the topics, okay? So if you hear the word Kafka topic, just see it as a container which we use to store those messages, those data that come from the outside into Kafka, okay? So when a message comes from the outside, gets into Kafka, it goes directly into this topic, okay? And topics are log of events. That's the common definition out there. But it might be difficult for beginners to understand, logs. So logs. So they are log files. They are log files because those things are computers. So, it's a log file, data on top of those. So they save some data there. So, but just see it as a container, where we store all those messages. Now let's go to partitions. Don't worry, there's a lot of noise here, but we are going to talk about this. So within the Kafka topic, you usually have partitions. So that means that topic is further divided into partitions. So see the topic as an apartment and the individual room there are partitions. That's the thing. So that means all your messages that are coming, they are going into those rooms. They are going into those partitions. So when you are creating a topic, you specify how many topics do you want, how many partitions do you want? That's the thing. If you want one, if you want two, if you want three, if you want five, it's entirely on you. But this is one thing. In as much that data engineers, we don't really care about, creating a topic because we are sometimes at the other hand, consuming the data that goes into Kafka. But it's still important for us to care about it because the people creating the topic, they need to understand that if you have small amount of events that will be coming into that topic, there's no point for you creating a lot of partitions. But if you have a super high volume of events, I can't imagine Amazon.com. They will have a lot of events. Netflix, they will have so many events. So I expect their topics to have a very, very fat partitions. I won't be surprised if it's even 100 partitions or more. So yeah, that's what it means basically. So, and Kafka distributes the partitions among the brokers. So we've talked about this the other time. So when I said Kafka will replicate those partitions among those brokers. So it's going to make a replica of them, of these partitions on top of those brokers. So even though one computer failed, or maybe it's dead or something like this, I don't know. So you already have a copy of your data in another machine. So that's why it's even fault tolerant. So just to reiterate around that. Now, in short, every message that goes into a topic, they end up where? In a partition. Now let's talk about the last one. This last one, easy one. Those messages, they are coming from somewhere, right? And they go into a partition. But we need to number them. We need to give them some kind of, identity. So in this case, see it as a unique identifier, okay, for that record or for that event or for that message. So they typically start from 0. So that means the first message that comes into a topic, we get the identity 0. So that's the unique identifier for that message. So, and in other words, see offset as the position of an event in a partition. So, and that's the reality there. And now let's move. Now, this is it. We are going to do this again. We've represented this thing in the past. This last slides. Our brokers. The cluster itself. But now we are going to deal with the broker now. Okay. So we want to talk about the broker. So we want to represent it visually so that we see what we usually have there. Now we have a Kafka broker, and we know that this broker, it's usually part of a cluster, right? The last time we had 4 brokers. Now we are picking one of those brokers just to be able to see what we have there. And now you usually have a topic, that goes on top of those brokers. And in this case, the name of the topic is called orders. Maybe this guy is going to get in, every orders that comes on our website goes into this topic. Okay. And we already said what, a topic can have one or more partitions. In this case, it has just 2 partitions. Okay. And what happens? Messages start to come in. So someone placed an order, I don't know, on Amazon.com, and the message comes. So when that message goes into what? The first partition. And as you can see right there, that's the order. The person placed the order and the person bought bread. And the second message comes, goes into the other partition. Can you see? They have the same offset, but they are different. So that's one thing you need to know. The fact that these 2 messages, they have the same offset doesn't mean that they are the same. So they are different. Okay? So they are different. And just hold on there. So we continue to have these messages. They start to roll in. But at the end of the day, we already know that what? All these guys, they are what? They are offsets. So they are offset, but they are records. The offset is just their position or their unique identifier. So that's what it means, basically. So the actual record itself, the actual event itself is stored, but it has to have a number, like a number. So just see it as a number. So, that's the thing there. So, and now I think that's all we need to talk about here. It's very easy here. So we have the broker. So a topic is inside the broker, a partition will be there, and individual messages comes, and they get stored, inside those partition. And yeah, let's now move forward. Yes, it's starting to get interesting now. So let's talk about producer, consumer, and consumer group. In as much data engineers doesn't really care about the producer, we care more on the consumer and the consumer group. But I believe people on the call might not just be a data engineer. Tomorrow they might find themselves, creating a topic. I've created a topic as well in the past. But mostly, software engineers are, back-end developers. So they are the one mostly, creating those topics. So now let's start and, talk about what these things are. Look, it's very easy. Any application that writes into Kafka, they are called producer. It's as simple as that. Again, any application that writes, so that application capture an event somewhere and writes into Kafka, that application is what? Is a producer. Human being is not a producer. So when I was starting out, I used to think that, they are human beings. So I usually be like, human being, okay, those are the engineers, no. So those engineers, they are the author. They own the producer application. And this producer application, you can write it in any of your preferred language, Python, Java or whatever. So their application actually. So the consumer, you can already guess. Any application that reads from Kafka, it's called consumer. Again, you can write this in your preferred language. So, and now the consumer group. There's no ideal definition for this, but Kafka used the concept of consumer group. And the concept is it allows multiple consumers to form a group so that they can consume together, from a topic in parallel. So, and that group can contain one or more consumer instance. Okay, so when I say consumer instance, it's like consumer application, so one application is an instance. Okay, so that's the idea behind consumer groups. So from this, what I have here, consumer group allows consumers to work together to process messages from a Kafka topic in parallel. So that means it depends. So there are some other concepts there, but we are going to talk about this part because this part needs to be what? Needs to be crystal clear to data engineers, especially people, everyone, not just data engineers. Anyone that is, building a consumer out there or that uses consumers. Yeah. Now let's go into the detail of these guys. Okay, let's see it. Let's see it, how they relate together. Let's see everything. Okay. And please pay attention here. I have a lot of things transitioning up and down. It's just for us to be able to understand this. Yeah. Typically, we are going to have a cluster. And when we have a cluster, you can already guess that within a cluster, we have a Kafka topic there. So, and we know that this topic goes on top of a broker. And this one is just Kafka topic A. So, for example, and we know that when we have a topic, then definitely we should have a producer somewhere that wants to write into that topic. But in this case, the producer is a Python application. So we don't know where the producer will be getting data from. Now, it's planning to capture some events from Netflix and Amazon. I just use this source, sorry. It can just be one. So it doesn't mean that the same producer is going to the two places. So, it can be any of this. So the idea is that this producer will what? Go to any of this place, capture some events there. So maybe the movie that you're watching, or maybe something you just bought. So, and what happens afterwards? The idea is that they need to write into Kafka. So that means that producer goes into Netflix or Amazon, capture the events there, and send it to Kafka. That's the job of the producer. And we already know that there will be a Java application who is acting as our consumer right there on the right-hand side. And what is this guy meant to do? This guy is meant to consume from this topic. But the reality in Kafka is this consumer cannot go into this topic to consume because it needs to join a specific consumer group. That's the rule. That's the rule. So that's why when you are creating your consumer application, there will be a part there whereby it will ask you that what's going to be the name of your consumer group. So automatically, when you deploy your application, Kafka is going to create that group itself. So once this guy now is available inside a specific group, guess what's going to happen? This guy is going to read and write the data to a specific location. In this case, we're just writing to a database. So this is what it looks like. This is the relationship between these three. Okay? But now this is good. Things are fine like this. Because let's assume that our producer is capturing two fields. Let's assume that it's a name and location. And it's capturing this into Kafka. Then our consumer is capturing that name and location, sending it to our database. But one day, what happens when this guy, this producer, maybe the person who owns it, just remove one of the field? Then that means what? There will be a chaos on the consumer side because this guy used to listen to just two fields, but now they've removed one. Now this consumer will struggle. It's going to break. It's going to break. But now, how do we solve this problem of data inconsistency from the source, from the downstream? How do we solve this? The answer is what? Kafka schema registry. Kafka schema registry. Look, this part, it's a, I don't want to say this, but it's some sort of a complex, not really complex, I would say, depending on how complex you want to go. But as for me, and I believe what I'm going to show here, it's enough for what you have to understand. When you start to implement, then you understand it even way, way better. But whatever you're going to implement, we revolve around, what I'm going to show you here. Okay? So now let's go and talk about what Kafka schema registry is all about. Now we start from a journey of Netflix. So let's assume one of us, Musili, for example, sit back today on Saturday, watching a movie with our family. And now you already know Netflix, they want to make money. They want to engage Musili's family. They want to ensure that they are not leaving that seat. They are always on Netflix. And guess what? Netflix is going to call John Doe, who is a software engineer that works at Netflix. And what are they going to do? They want to create a what? A consumer application that is going to go to Netflix, capture all of the events happening on Musili's family side. And the idea is that what? They want to send that to Kafka so that an underlying consumer can consume those events and do what? Maybe send it to their recommendation system so that before Musili and her family finish, they will already recommend another Yoruba movie, or I don't know, like, Yoruba, it's another tribe in Nigeria. So, so they just want to engage her, and they are not going to wait, just like what I said, they are not going to wait for you to finish that movie. They are already planning for you before you finish. So what is going to happen in this case? Oh, okay, before this, sorry. So now the producer and the consumer are in this different direction. Now they have to be like, yes, consumer will be like, producer, please. Hope you're not going to change anything. Hope what you're sending is what you're going to send, because we need to track what's going on with Musili's, family. I mean, what they are watching, nothing must change. If you said you are sending 2 fields, let it be that 2 fields. Please don't change anything. But you already know that people can change, right? The people who owns this application, one of them can just be like, just do something with the code and maybe just remove something. But in this case, for us not to give room to any kind of error, this is where schema registry solve that problem. But what is schema registry? See schema registry as a centralized repository. I mean, not GitHub repository, sorry. So as a centralized repository where we manage Kafka topic schemas. So when we say schemas, it's just the fields of what you're sending, the fields. So you define the name of the field and the data type of that field. So if you're saying you want to capture name, you need to mention the data type, which have to be a string. So, and you need to have it. So it's standard. So now once schema registry can solve this, so the producer, the people who owns the producer and the people who owns the consumer already agreed on a contract, on a data contract, that please, let's create what? A unified schema, and let's register that schema in what? In the schema registry. So what is going to happen? Now our software engineer guy, they have to tell him to what? Go ahead and create that schema and bind it with a topic. So create that schema, bind it with the topic which this producer is going to write into. So now after this guy, John Doe, is done with that, so what's going to happen? I mean, it's not that easy that the producer will now write into Kafka. No. So that means once the producer captures those events, it needs to what? Go to schema registry, fetch the schema that they have for that topic that he wants to write into. Once it fetches it, then what is going to happen? It's going to now serialize the data based on the schema that it fetches, with the schema, right? And now send it into Kafka. But of course, Kafka is very smart. Kafka is not just going to be like, just come in, the data. I mean, those brokers, they are very smart. And what's going to happen? The brokers have to validate that schema first. So there is a link between Kafka cluster and the schema registry. So the schema registry is not part of the cluster at all. So now once they validate that the schema exists, then they can be like, okay, yes, we can allow that your data, we can store it into the right place. So that's what the process looks like there. So again, a producer captures an event from Netflix. Before he can send that event to Kafka, he needs to go and fetch the schema, of the topic. And once they fetch that schema, then they serialize the data with that schema into Kafka. Then Kafka validates that. I mean, the data is still hanging, but Kafka has to validate that schema before they now allow, the data to now be serialized successfully into Kafka. And now you can already guess, on the consumer side is the same thing as well. Fetch the schema, deserialize the data. But guys, there's 2 things that I want to pay your attention into here. There's a word called serialize, and there's another word called deserialize. What's the meaning of these 2 words? Let's cover that in the next slide. But before we can talk about that, it's important that we talk about one big secret about Kafka. You can already see that lady. Can you keep a secret? No, she can't. And the same thing with myself. I can't keep this secret. No, I can't. Because I didn't know about this secret until my boss, my previous boss, showed me, Nicola Koda. So showed me at work, and I was surprised. So because I didn't know, but it's always good to know things like this. So now let's find out what this secret is all about. So again, we start with a typical Kafka cluster, right? And we have a Python application acting as our producer here. And this our producer wants to what? Capture this data called MyOR, wants to capture this data, right? And we can already know that what? We will have a Java application acting as our consumer on the other side, because he wants to consume that MyOR once he gets into the Kafka cluster. But look at this. Now this guy wants to write MyOR into Kafka, right? I mean, that would be what you will guess. But no, this is not happening. It's not possible in Kafka. MyOR is a human readable word. I mean, it's a human readable word. And you cannot send that human readable word into computer machines. They don't understand what that word is. They don't understand it. I mean, and the only word those computers, I mean, those brokers, they understand is what? It's bytes, zeros and ones. So when my boss told me about this, I was surprised. I mean, everything you send to Kafka, they are bytes. They are bytes. So not the actual word itself. So the process of you converting MyOR into these bytes is called serialization. Okay? So it's the job of this Python, I mean, this Python application, to ensure that it captures that MyOR and convert it into bytes. So again, it's not that we have to find a way to, I mean, how do we know it's 0 or how do we know it's 1? I mean, I just made up a random number here. So there are frameworks that convert this. So just for your information. So now you can already guess. I mean, the same thing applies on the other side. That process of you converting those bytes from bytes to that human readable words, I mean, it's called deserialization. And once the data is being deserialized, you can already know what happens, right? You know, MyOR will be sent to wherever that they want to send it into. So this is the secret about Kafka. I mean, someone might ask you out there, or you might stumble across, you know, any article there. I mean, whatever goes into Kafka is bytes, you know, so it's bytes. And that's the secrets about Kafka. I mean, it's amazing that we've exposed Kafka and we've learned about what serializers and, you know, deserialization means. Again, there are, you know, many serialization frameworks and deserialization tools. So, I mean, by the time you start working with Kafka, I mean, you know, you see quite a lot of them. So, yeah. And now let's go into consumer group and rebalancing. There's one thing that I used to say. Anyone who is on the consumer side, if you're part of a team that manages a consumer application, these two things have to be really, really clear. Consumer group and rebalancing concepts. It has to be extremely clear. Otherwise, you will be confused when your application starts to rebalance. When your application starts to rebalance, it's just a shame that I'm not able to explain a concept. I mean, it's not part of this slide. I mean, it's called consumer lag. And I mean, I'm supposed to add it, but I mean, somehow, I mean, I don't know. So, but I just felt like it's a vital information out there, but I mean, it's good. You know, what you're taking away from this as well is, you know, massive value. Now, let's start to explain this, guys. The first thing is what? We have a Kafka topic that is called movies. So we assume that it's Netflix, you know, from Netflix. Maybe they created, I don't know, a Kafka topic called movies. And we know that within this topic, it has two partitions, partition 0 and partition 1. And what? We have this number of messages. being published into this topic from our producer, but we are not showing our producer, so we are just assuming. And on the other hand, on the other partition, we have these 4 messages there. So that means 4 events or 4 messages or 4 data or whatever we want to call it. Now, ideally, we will have what? A Python application, which is going to act as our consumer. Now, this consumer, you already know, we covered it in our previous slides. This guy cannot go to this topic to what? To consume. Kafka said, before any application can go into Kafka to consume, they need to belong to a group. They need to belong to a consumer group. And now, once this guy belongs to consumer group A, this guy can now start what? Consuming the data, doing all of the work, all by himself or by itself, all alone. But look, this is Netflix. You can already know the number of people, streaming, the number of data, that will be going into this topic. It's fine at first, right? It's fine, this guy alone doing all of the work. But what happens when the number of messages starts going to millions per minute? Starts going to millions per minute, like millions per minute. That means this guy will struggle. This consumer application will struggle. So that means there will be a lag. There will be a lag because what is going into the topic is now more compared to what this guy has processed. So the difference there is called consumer lag. So let's assume the number of messages in this partition is 1 million, or the entire topic is 1 million. And so far, this application has consumed 200,000. Then the consumer lag there is 800,000. So that means your application, it's here to consume 800K. So that thing usually scares us, we that manage consumer applications, because when you start to see lags, man, you can already be like, oh man, what's causing this? So it's important to know that, please, I will say some of you should read around this consumer lag, but that's the thing, Sha. That's the thing. Sorry. So that's the thing. So the difference, basically, that's the consumer lag there. So now that means if you create this your application, I don't know the medium where some of us deploy our application, but in our own case, for example, we deployed our Python application in Kubernetes. So, and for people who doesn't know, some people knows Kubernetes, they knows that it's a system that scale. It's a system that scale a lot. So Kubernetes is a container orchestration system. It's a distributed container orchestration system. So typically the journey starts from you building your application, right? You start developing your code, then you Dockerize it. So when you Dockerize it, you turn that into an image, and you put that image in a specific, container registry. And easily you can now, the image, in a container registry. And easily you can leverage Kubernetes to be able to run that your application for you. So now in our case, that means we can easily scale this our consumer application to be 2. So that means we just have to go to where we define this our application and say, hey, you have 1, please, I want to have 2. You just change 1 to 2. It's replica for people who understand Kubernetes here. So we turn it to 2. Now, second application join this group. But in this case, that means this guy is still processing, right? But as soon as this guy joins, Kafka is going to do what? It's going to trigger a rebalancing because we now have to consumer instance. So everything has to stop. Everything has to stop. And during this period that the rebalancing is going on, no consumption is going to happen. So that means your producer is now still sending messages into your topic. So that means you should expect high consumer lag. So, and sometimes when you have a consumer lag in production, at work, you want to go and check your application that, oh, look, is your application dead? Or are you having some sort of rebalancing? So, and there are many things that triggers rebalancing, and this is one of the case. And in this case, rebalancing is happening because Kafka wants to shuffle, wants to balance the workload among those two guys. It will be unfair for just one person consuming. I mean, it's unfair. So now what happens in this case? Once the rebalancing it's done, now the load will be evenly distributed, among these guys, among those consumer instances. So now they can now start to, consume in parallel. So that was what we had in our previous slide where we said, these consumer instances within the group, they can consume in parallel. So, and now let's look into a scenario whereby we have another application coming in. So we now have to scale our application. Maybe some people doesn't know. So they now scale the application again. So we have 3 instances of that application. Can anybody guess from the call? Anybody? Can you guess what's going to happen? Anyone? Anyone from the call? No worry, it's fine. Okay. I mean, in this case,
Rebalancing.
Okay, man, I already brought, I mean, it's fine. Oh, sorry. So in this case, this one consumer will just remain idle because the rule says 2 instances of an application of a consumer within the same group, they cannot consume from the same partition. It's not possible. It's not possible. So that means this guy will just remain idle there. I mean, it won't do anything. So these are some concepts that we need to know. I mean, because we never know where the journey will take some of us. So just for us to know. And there are many things that triggers rebalancing, to be honest. For example, if they increase this partition to 3, rebalancing will kick in. Definitely, because again, rebalancing will happen. And Kafka has to what? Shuffle. I mean, balance the workload. But one thing that I want to tell you guys here is this. There's a lot of things, going on here. There's a lot of things going on here. But that's what you need to understand. The rebalancing protocol itself, I mean, it's deeper than what I'm explaining. But we don't want to bore, us here. So easily, this will serve as a baseline for you to go and read around it if you're interested. But typically what you have to know is this. What you have to know, you can always extend it. I mean, I can tell you this. Now let's go to the next one. The last section is Kafka Connect. What is Kafka Connect? Look, they are a bunch of already made connectors. And their job is to what? Move data from a specific source into Kafka and move data from Kafka into another system. So they are already made connectors, okay? Now we have 2 types of those connectors. We have the source connectors. These are already made connectors used for moving data into Kafka. So that means you don't need to write any code. Just leverage these connectors, okay? I mean, there are many of those connectors out there. There are a lot of those connectors out there. So just check the documentation and you'll see how to configure them. So you don't have to write code. So it's already made by some folks, some people in the community. And of course, the sync connector in this case, they move data from Kafka into another system. So that's what they do. But now we are going to do this. Let's look at this visually, okay? So let's talk about the source connector first. Let's see it visually. First of all, when we say Kafka source connects, we can already know that we have to talk about the source. So in this case, our source is a Postgres instance, okay? A Postgres database, instance, whatever. And this guy, we want to get some data from this database, into Kafka. And I mean, for me in the past, I mean, what we leverage is a connector. So you can leverage what? A source connector for this. And there's a lot of those source connectors out there. One of the popular one is the Besium connector. So you just have to connect it, configure it together, with the Postgres, with the source system, which is this Postgres database. And when you do this, it reads from that database. So it captures all of the changes that happens there. So that concept is called CDC, change data capture. So basically you're saying, please, this connector, help me to capture every changes that happens inside this my database table. So you have to specify those tables. And anything that happens there, if someone should insert a new record, it's going to capture it. This connector is going to capture it. If someone should delete anything, it's going to capture it. If you modify anything on that table, it's going to capture it. And after this connector capture that thing, guess what? It's going to write that into what? Into Kafka. Into Kafka. It's going to capture it and send it into Kafka, into a specific Kafka topic. That's what happens. I mean, that's the whole thing, around, source connector. So the whole thing is the documentation to read on how to configure the source connectors. Okay, so this is not the only source it integrates with. So there's a lot of sources. So S3 is there, a lot of sources, a lot. Now let's talk about the sync connector. Now Kafka sync connector, want to see this visually as well. So we already said is what? They are connector that moves data from Kafka outside, right, to another system. So that means the journey will start from, having those, the events in a Kafka topic. So let's assume it's that's the ones that we wrote into Kafka from the Postgres database. Now the data now lives here. What do we want to do? We want to move that data into our data warehouse. It could be Snowflake, Redshift, anyone. And what do? We still want to leverage our sync connector. So that means you have to configure the sync connector to be able to what? To read from the topic and write into your destination. This is what it looks like. This is what it looks like. Okay. And if you need to scale this, your connector, in terms of the consumers, you just have to increase the task, the number of tasks. So if you increase the number of tasks, there is a settings there. If you look at the documentation, everything is there. That's the source of truth for everything. And now that brings us to the end of this webinar. Now, before I start.
Yeah.
Okay, so what I just want to say is, I'm already running Kafka locally as well. So as you can see, I'm sending some messages to Kafka. And in this case, I'm doing what? I have a producer, sending messages to Kafka. Okay. And I have a consumer writing that data to Kafka, to S3. So as you can see here, so, and the data lands in S3. So, and I'm able to see the data here, in real time. So the repository is here. So I'm going to share this. This is the repository here. It's a basic one. So, and everything, from infrastructure to the architecture, all of the tech stacks that I use here, it's here. And I explain everything, basically. So just for, people to be able to understand, what's going on in the repo. So again, I'm not usually a big writer. So I stopped here. So, but I'm going to share this in the community so that, people can have a look around this. The producer lives inside this place. The producer application lives here and the consumer as well. So, and people can use this to, practice to themselves. So I think that's going to be it. Thank you.
Thank you. Thank you, everybody, for joining. Have a beautiful evening.
No worries.
I'll see you wherever you're joining from.
All right. Ciao.
Thank
guys.
you, everyone.
Bye. Yeah.